We're going to talk about parametric experiments now. So with a parametric experiment, there's more than one independent variable on the dependent variable. So whereas in the past we talked about a bivalent, where there's two versions of one independent variable, or a multivalent, where there's more than two versions of an independent variable. With parametric experiments, there's more than one independent variable. So there are at least two separate independent variables. The main effect of one independent variable can be examined at the same time that the main effect of another independent variable is studied on the dependent variable. Because we have more than one independent variable, we also look at the interactions that the two independent variables might have when they cause changes in the dependent variable. It's more economical and efficient than a bivalent and a multivalent experiment because more independent variables can be examined in a single experiment. So this is a very strong experiment, a quantitative parametric study. It's rare to encounter a single independent variable that can account for the entire causation of change in any dependent variable. For example, communication between a talker and a hearing-impaired listener, there are several variables that might affect intelligibility. The acoustical characteristics of the talker's speech, the noise level in the background, the distance between the talker and the listener, the reverberation in the room, the type and severity of the listener's hearing loss, the amplification properties of the hearing aid, the familiarity of the listener to the topic. So there's more than one independent variable that can be looked at. It's important to design an experiment that examines the simultaneous effects of many relevant independent variables that may cause changes in the dependent variable of interest, and that is a parametric experiment, which we've been talking about. Here's an example of a parametric experiment. So again, we have the independent variable on the x-axis, and that's finger spelling length, and then we have the dependent variable on the y-axis, mean ratings of speech naturalness. So we have two separate independent variables with speech only or with simultaneous communication. Okay, so two independent variables looking at finger spelling task length on one dependent variable. The main effect is the individual effects of each independent variable on the dependent variable. And because we have more than one independent variable, we also have to consider that they might interact with each other. And that's called an interaction effect, which is the simultaneous effect of the independent variable and the parameter on the dependent variable. So when you have two or more independent variables studying simultaneously, you also have to look at their interaction effect. Beyond having like three independent variables, things start to get very complicated because then you have to look at the interactions between A and B, B and C, A and C, et cetera, et cetera. So the more independent variables you have in the parametric experiment, the more interaction effects you may have, and the more complicated things will get. Here's another example. Results of a parametric experiment showing the interaction effects of subject age and sex on the time between onset of upper pharyngeal pressure and upper esophageal sphincter relaxation while swallowing. It's a lot to say. But basically, they have age and then they have gender. So two independent variables, young and old, male and female, on one dependent variable time. Two independent variables. Example, the dependent variable may increase as a function of the increase in the independent variable for one value of the parameter, but the dependent variable might show no change as a function of increase in the independent variable for another. So one independent variable might have an effect on the dependent variable and another might not. Whenever the form of the function relating changes in the dependent variable to change in the independent variable is different for different values of a parameter, you also have to consider an interaction effect. So to summarize what we've spoken about, experiments can be categorized as bivalent, one independent variable with two categories, multivalent, one independent variable with multiple categories, or parametric, separate independent variables, two or more separate independent variables. So again, bivalent examines the effect of two values on one independent variable, on one dependent variable. It's appropriate when the independent variable can be dichotomized. It's inappropriate for studying independent variables that can be continuously manipulated, especially when we examine nonlinear functions. For that, we would do a multivalent experiment where we have several values of one independent variable on the dependent variable. This is more comprehensive and accurate than a bivalent experiment in determining the functional relationship when the independent variable is continuous. And then we have a parametric experiment, which is appropriate for studying simultaneously for more than one independent variable on one dependent variable. Okay, and then with the parametric, we also have to think about interaction effects.